Hey guys, today we're going to be doing the area of a triangle, but we're going to be doing it slightly differently than we're used to. Alright, most of the time you would have seen the area is equal to half times the base times by the height, and that height is perpendicular to the base. So, what we're going to be doing is looking at non-right angled triangles. You're going to see this triangle referenced a lot when we're talking about non-right angled triangles. It has angles A, B, and C in capital letters. So this angle in this corner is the capital letter A, and so on and so forth, B and C. The sides opposite those angles are the lowercase of those letters. So the side opposite capital A is lowercase a. The side opposite capital C is lowercase c, and same for B. Okay, this little note just tells you what I just mentioned here. And what we are going to do is come up with a slightly different form for the area of a triangle. So we're going to use our idea of half base times height and work out what it is, but in terms of sine. So let's take this angle here. We've created a perpendicular line to the base B, and we want another expression for the height. So sine of C, sine being the ratio of its opposite side to the hypotenuse, so opposite is h over the hypotenuse, which is a, and you can rearrange and you get the height is equal to a sine C. If you substitute that into your idea that we had right at the beginning, half base times height, then you get the area is equal to half base times height. Substitute base is b because the height is perpendicular to it, and the height is what we had just a second ago, a sine c. So half b a sine c, or we rearrange it, and this is the form that you'll see the most, this one here. A is equal to half AB sine of C. So C is the included angle, and you're going to see this referenced every now and again as well. Included angle comes up in the cosine rule, which we'll do in another lesson. So the included angle means that in between the two sides that you are using is the angle that you are also using. Let's run through a couple of examples of how this looks. Okay, so we have our first example. Find the area of this triangle here. We've got an angle of 43 degrees at the tip here, and that its sides are 5.7 and 3.7 meters. Now, is the angle in between the two sides that we know? Yes, it is. It is the included angle, which means we can use that the area is equal to half AB sine of C. Substituting, it doesn't matter which one's A and which one's B. Half of 5.7 times by 3.7 times by the sine of 43 degrees. And let's go to our calculator. Half times 5.7 times 3.7 times by, calculator is definitely in degrees, it's worthwhile checking regularly. Sine of 43 degrees, and we get 7.1, and I'll just go to two decimal places, 7.19 over here meters. Now it doesn't necessarily have to be used for just triangles. If we can divide our shape into triangles, for example, we've got our parallelogram here and we've got sides of 12 centimeters and 7 centimeters. And one of its interior angles is 105 degrees. Now with parallelograms, you're going to have one acute and one obtuse angle. We're going to talk about the obtuse angle, 105 degrees, and we're going to create two triangles that look like that. Opposite angles in a parallelogram and opposite sides are equal. So we actually have two triangles that are exactly the same with an included angle of 105 degrees. So the area of the parallelogram is going to be two of these triangles. Area of parallelogram is half, but I'm multiplying it by 2, so I don't need to stress too much about that. It's just going to be, I'll write the whole thing out just in case. 2 times half, AB, A is 7, B is 12. Opposite sides are equal, so this and this, times by the sine of the included angle, 105 degrees. Okay, the 2 and the half are going to cancel, so we can not really have to worry about that. So what I'll just type in my calculator is 7 times 12 times the sine of 105. Enter. Let's approximate that for now. It's equal to 81.14. Again, I don't think I've given any accuracy in the question, and I generally like to go to 2 decimal places. That's just me. Centimeters squared. Ooh, that's something that I missed out on the previous example. 7.19 meters squared. We're talking about area here. My mistake. Alright, our last example 3. We've got a house garden bed in the shape of an equilateral triangle with sides 12.5 meters. Find the amount of topsoil needs to go into this garden if it needs to be 200 millimeters deep. Well, let's do a quick sketch. We've got an equilateral triangle. They're all 12.5 meters each side. And we want to, well, an equilateral triangle has 3 equal angles, so they are all 60 degrees. It doesn't really matter where we start here. The area is still half AB sine C half of 12.5, and sine 60. And yeah, we'll work this out right now. Half times 12.5 times 12.5 times sine of 60 gives us 67. Oops, I've already forgotten it. 67.66, approximately anyway, meters squared. And we want to find out the amount of topsoil needed to go down. It's got a depth here, so we're going to be working out the volume. Volume is equal to my area times by the depth. So my previous answer, which I would like to not round, so I'm going to carry that in my calculator, but the depth needs to also be in meters, so 67.66 times by 0.2 meters, and we'll get I'm going to take my answer from my calculator, however you decide to do that, and then times that by 0.2 meters. 13.53 meters cubed of topsoil. Pretty straightforward equation, I suppose. Hopefully this helps you out. Let me know if you have any questions.